Hello everyone. Today we're going to multiply radical expressions. So in our examples today, we're not going to consider the indices and radicands of the radical expressions. So now, let us have an example. Number 1, let's say we have square root of 2 plus square root of 5 and then times square root of 2 minus square root of 3. So here, we're going to make use of the FOIL method. Okay, so F stands for the first term. So we have square root of 2 times square root of 2. So let us now have the step-by-step process. We have square root of 2 times square root of 2. Then, O stands for the outer terms. We have plus square root of 2 times this one, negative square root of 3. Then plus. I stands for the inner terms. So we have square root of 5 times square root of 2. Then L stands for the last terms. So we have square root of 5 times negative square root of 3. Then let us now multiply square root of 2 times square root of 2, that is square root of 4, or simply that is 2. Then square root of 2 times negative square root of 3, that is negative square root of 6. So you're going to multiply the radicands, okay? Then plus square root of 5 times square root of 2, that is square root of 10. Then square root of 5 times negative square root of 3. So 1 times negative 1, that is negative 1. Then you will just multiply the radicands. So we have negative square root of 15. Okay, so you cannot combine these terms because they are dissimilar radicals. So this is the answer for number 1 example. Okay, next, number 2. Let's say we have 5 minus square root of 2 times 6 plus square root of 3. Okay, using again the FOIL method, we have F, first terms. So this is again using the FOIL method. F for the first term, so 5 times 6. So again, let us write for you to understand it well. Then O stands for the outer terms. So we have 5 times square root of 3. So the numerical coefficient here is 1. So since that this is a whole number, so you're going to multiply 5 times 1, that is 5. Okay? So plus 5 times square root of 3. Then I for the inner terms. So we have plus negative square root of 2 times 6. Then plus L stands for the last terms. So we have negative square root of 2 times square root of 3. So 5 times 6, we have 30. Then 5 times 1, we have 5. Okay? So plus 5, then you will just copy square root of 3. Then negative 1 times 6, so that is negative 6. Then you will just copy square root of 2. Then minus, because negative 1 times 1, that is negative 1. Then you will just multiply the radicands. 2 times 3, we have 6. So square root of 6. So this is the answer for number 2. We have 30 plus 5 square root of 3 minus 6 square root of 2 minus square root of 6. 3. let's say we have square root of 2 plus 3, and then times square root of 2 minus 3. Okay, so notice that we have here two binomials, right? So we have, for the first binomial, the first term is square root of 2. For the second binomial, the first term is also square root of 2, so they are just the same. For the first binomial, the second term rather is 3. And then for the second binomial, the second term is 3 also. So they are the same. Only that we have here, for the first binomial, the operation is plus. Then for the second binomial, we have minus or subtraction. The operation is subtraction. So if this is the case, so this is an example of sum and difference of two terms. Now, we all know that if we're going to get the product of the sum and then difference of two terms, what are you going to do is you're going to square the first term minus square the last term. You're going to square the last term. So here, we have to get the first term, which is square root of 2. Then square it minus the last term, which is 3. Square it also. So we have here square root of 2 squared. So that is 2 itself. So the radicand. Then minus 3 squared is 9 because 3 times 3 is 9. Then we have here 2 minus 9, that is negative 7. Okay. So let us put aside here, okay? For those who do not know why is it that it becomes 2. So if we have square root of 2 squared, this is equal to square root of 2 times square root of 2, okay? So 2 times 2, that is 4. So square root of 4, that is 2. Or simply, if you're going to get the square root of a number, so the answer is the radicand itself, okay? Let's say square root of x squared. The answer here is x, okay? Then square root of 5, then squared. The answer is 5, okay? So that's the answer. Okay. Then number 4. Let's say we have 5 square root of 3 plus square root of 2. Then we have 5 square root of 3 minus square root of 2. So again, this is an example of sum and difference of two terms. So what are we going to do is that we're going to get the first term, okay? So we have 5 square root of 3, then square it, then minus the second terms of the binomial. So we have square root of 2 squared, okay? Then let us now simplify. 5 squared, so that is 25. Then square root of 3 squared. So we all know that if that is the case, the answer is the radicand itself. So times 3, okay? Then minus, again, square root of 2 squared. The answer is 2. Then we have 25 times 3. So this is 75. Then minus 2. We have 73 as our answer. Okay? So that is number 4. Next, number 5. Let's say, for example, we have x minus square root of 5. Then times x plus square root of 5. Again, this is an example of sum and difference of two terms. So we're going to get the first term. So we have x square it minus the second term. We have square root of 5. Again, square it. Then we have here x squared. Then minus 5 squared. Square root of 5 squared, that is 5. So you cannot combine these two terms. So the answer for number 5 is x squared minus 5. Okay? Next, number 6. Let's say, for example, we have 5 minus square root of 3 squared. Okay. So, meaning to say, if this is the case, meaning to say, you're going to, this is equal to 5 minus square root of 3 times 5 minus square root of 3. So, what are we going to do is that we're going to make use of the concept of getting the product of a square of a binomial. Okay? So, square of a binomial, wherein if we have x plus y squared, its product is equal to x squared plus twice the product of the first and then the second term plus square of the second term. If this is minus, the middle term should be minus also. Okay, so going back to our example, we have, this is the first term, 5. The second term is square root of 3. So, we're going to square the first term. Since that this is minus, so minus twice the product of the first term, 5. And then, the second term, square root of 3. Okay? Then plus, you square the second term. So, we have square root of 3 squared. Then, we have 5 squared, 25. Then, 2 times 5 times 1. So, that is negative 10. So, negative 2 times 5 times 1, we have negative 10. Then, you will just copy square root of 3. Then, plus square root of 3 squared. We all know that the answer is 3. So, plus 3. Now, you're going to combine similar terms. We have 25 plus 3. So, we have 28. Then, minus 10 is square root of 3. So, this is the answer for number 6. 28 minus 10 square root of 3. Next, number 7. Let's say, for example, we have square root of x plus 5 squared. Again, using the concept of finding the product of the square of a binomial, okay, we're going to get the first term, then square it, plus twice the product of the first term and then the second term. So, times 5. Then plus square of the second term. Okay. Then we have square root of x squared. So, we all know that if this is the case, the answer is the radicand itself. Then plus 2 times 1 times 5. So, that is 10 square root of x. Then plus 5 squared, we have 25. So, number 7 answer is x plus 10 square root of x plus 25. Next, number 8. Let's say we have square root of 2 plus 5 square root of 3 squared. Okay. So, again, we're going to make use of finding the product of a square of a binomial. So, we're going to get the first term, square root of 2, square it, plus twice the product of the first term, and then the second term. So, 5 square root of 3. Then plus 5 square root of 3 squared. So, square of the second term. Then we have square root of 2 squared. We have 2. Then plus 2 times 1 times 5. So that is 10. Then square root of 2 times 3, we have 6. Okay. Then plus 5 squared, we have 25. Then square root of 3 squared, we have 3. Then we have here now 2 plus 10 square root of 6 plus 25 times 3, we have 75. Then let us now combine similar terms. We have 2 plus 75. So we have 77 plus 10 square root of 6. So that is number 8 answer. So next, number 9, our last number. We have 3 square root of 5 minus 2 square root of 6 squared. So again, first term, we have 3 square root of 5 squared minus 2 times the first term, we have 3 square root of 5 times the second term, we have 2 square root of 6 plus the second term, we have 2 square root of 6 squared. Then we have 3 squared, we have 9. Then square root of 5 squared, we have 5. So times 5. Then minus 2 times 3 times 2, the coefficients. So we have 12. Then square root of 5 times 6, we have 30. Then plus 2 squared, we have 4. Then times square root of 6 squared, so that is 6. So the radicand itself. So 9 times 5, we have 45. Then minus 12 square root of 30. Then plus 24. Because 4 times 6, we have 24. Then you combine similar terms. 45 plus 24. So we have 69. Minus, you will just copy this. We have 12 square root of 30. So this is the answer for number 9. That's it for today about multiplying radical expressions. For more videos and updates, please do like, comment, share, subscribe, and then click the notification button for more videos and updates. Thank you!